Now we are at 3.2.2. We are looking at our equation. First question we ask ourselves always before I start with differentiation: is my equation differentiation ready? No, why not? Because I have sats for the variable, and I also have the variable in the denominator. So what must happen now? Remove the sats by changing them to exponents. Number 2, take all variables that are denominators to be numerators. Let's do that. So we are getting it ready. We are getting it ready. We are not starting yet, ne? We are getting ready. The bride is getting ready. This one is ready. I'll leave it as it is. No differentiating now. And then number 2, the square root of x. Square root is x power half. It's power half. Then this one is also a square root, but here the square root of 4 is 2. Then the square root of x cubed will be x cubed power of half. It would look like this, but then otherwise you know that you're gonna say 3 over 2. What's that exponential rule? N. This is n. What did the rule say? If I'm changing this to an exponent, if I'm changing this to an exponent, it's gonna be a exponent n over m. So given that this will be x exponent 3 over 2. All right. Now this one, the problem is the x in the denominator. So I'm going to take it up. It's going to be 2x exponent -1, according to that law of exponents again that says if I have a exponent -m, if I have 1 over a exponent m, then I will have, if it goes up, it will be a exponent -m. So this is our exponential loss. Exponential loss. All right. Now we look at our equation. Is it now differentiation ready? The answer is still not. Why? We have an x at the bottom. Take it up. Let's do that. -2e. The ready ones don't touch until everything is ready. This one you have 2 and 2, so this is gone, meaning you have 1 here. Then you are going to have x exponent -3 over 2 minus 2 x power -1. This one is ready. Now we are differentiation ready. We can start with our derivative. So now we are looking for dy over dx. Let's go. -2e power 5 exponent x. What do? We multiply the 5 times the -2. I have -2 times 5 is -10e power 5x. Then here I will have half times 3 will be 3 over 2 x. Then half minus 1 is minus half. The next one is -2 3 over 2 times 1, that will be negative 3 over 2. Then x, negative 3 over 2 minus 1, it will be what? Minus 5 over 2. All right. So 2, is it showing? It's a 2. Then this one, negative 1 times negative 2 is plus 2. X minus 1 minus 1 is minus 2. Alright, we are done differentiating, but we were asked to take it back to positive exponents and SAT form. Alright, so all the negative exponents must change position to become positive, and all the exponents, the fraction exponents, must now turn into SATs. Let's do that. This one is perfect. I love is. Is perfect all the time. All right. Then negative exponent, so it must go down. It will be plus 3 over 2. Then the x comes to the bottom, x power half. Same here. X power 5 over 2 plus 2 over x squared. We are done with the positive exponents. Now we need to change all the SATs, or go back to SAT rather. X power half is the root of x minus 3 over 2. Then it was, if it's over 2, you know it was the square root, and x power 5. Plus 2. This one is all right. It's not a SAT because the exponent is not a fraction. All right, let me just explain this again. We are using here the rule that says, remember the rule said this. This becomes what? A exponent m over n. So now we are reversing from this side. We are going back here. You see that? Let me take an example with this. So here there's a 2, the 2 year square root. I just did not show it because you don't need to show the square root, the square for square root, or the 2 for square root. So yeah, I reversed the process literally. I just reversed the process. All right. Okay, stay tuned for 3.2.3.